Hello, students. We are all familiar with these acids, aren't we? But today, I want you to name the acid which is present in the stomach of the mammals. I'm sure you got it right. Yes, it's hydrochloric acid. Well, today, we will learn more about hydrogen chloride gas first, mainly its physical properties. So before that, we all know the molecular formula of hydrogen chloride is HCl, and the dot structure is this way, whereby the cross is the electron of hydrogen and the black circles are the electrons of chlorine. So let's know more about this gas. As you can see, it's colorless, its odor, it's pungent, not pleasing to your nose. It's choking, right? And whenever we deal with the gas, before we start making it, learn the laboratory preparation of this gas, we should be knowing its physiological nature. So the first thing, it's very important to know that it's non-poisonous, but if inhaled, it will irritate your nose, throat, and lungs. Now, when we discuss about the density of the gas, we always compare it with air. As you can see, HCl is heavier than air. And how many times? 1.28 times. Let's understand this by a very simple experiment. You bring an empty gas jar containing a lighted candle. So the air in the jar supports combustion of the candle. And then, as you can see, when you bring the HCl gas, and HCl gas is being, the HCl gas is going down, the candle got extinguished. Let me show you again. The candle got extinguished. Not only that, the air got displaced. That means HCl gas, being heavier than air, went down into the lower jar, thereby pushing the air out. Right? So what does this experiment prove? It definitely proves that HCl gas is heavier than air. Yes, of course, HCl gas also extinguished the candle, so it's a not supporter of combustion. But this experiment has more weightage on proving that HCl gas is heavier than air. Let's know more again. If you bring a blue litmus paper in the HCl gas, what do you feel? Well, there is no change. Dry HCl gas has no effect on the litmus paper. So what does that mean? It means that HCl gas is non-acidic in nature. Whereas if I moisten this litmus paper, I wet it in water, what do you feel will happen now? It will turn red. The reason is, this shows the acidic character of HCl acid because HCl gas got dissolved in the water of the litmus paper and it turned into acid, and it's the acid which turns the moist litmus paper red. So we also need to know the solubility. As we saw, HCl gas dissolved in water. So what can I say about the solubility of this gas? Yes, it is highly soluble in water. Let's understand the solubility of HCl gas in water by a wonderful experiment known as the fountain experiment. Let's see the setup here. You can see a trough below containing the blue litmus solution. And there is an inverted gas jar, inverted round bottom flask containing the HCl gas, freshly prepared HCl gas. As you can see, the mouth of the inverted round bottom flask that contains two things. One is a jet tube fitted in the mouth, and the other is a dropper. Now, this dropper contains water. So once your setup is ready, now we begin the experiment by squeezing the dropper. What will happen when you squeeze the water spills into the round bottom flask. And the moment the water has entered the HCl gas, what would happen? Yes, the gas will definitely get dissolved, because we know HCl is highly soluble in water. Highly soluble in water. So what would happen if entire amount of gas gets dissolved in water? The gas occupies larger volume, and then the acid occupies less volume. So there will be vacuum, or rather partial vacuum. Pressure will go down. As soon as the pressure goes down, what happens? The atmospheric pressure will try to go in, right? So this atmospheric pressure that's high will try to go inside the round bottom flask through the blue litmus. And there you go, the blue litmus jets into the jet tube. And see what happens when this blue litmus comes out into the round bottom. A beautiful red fountain is seen. So this experiment proves, first thing, that it is HCl gas is highly soluble in water. Because HCl is soluble in water, there was a partial vacuum created. Because of the partial vacuum, the blue litmus solution rushed through the jet tube and came out as red fountain. Now, why did it come out as red fountain? That shows its acidic nature. You can see this experiment in real. Let's observe. You can see the blue litmus in the trough below, and let's watch a beautiful red fountain being formed. I'm sure you enjoyed this class. Thank you so much.